For the fourth page, the graph of f is shown above. G is the definite integral from -3 to x of f of t dt. So I always want to make sure I'm marking where we're starting that. Find and justify the global maximum and global minimum of G. Now, you can definitely make a sign chart to help you out, but because we're talking about a continuous function on a closed interval, you're expected to use the extreme value theorem, or at least that's the easiest way. Because what a lot of people forgot, what they realize is, okay, so g prime of x is equal to f of x. And they notice at x equals 0, g prime changes from positive to negative, so g has a local maximum. And then at -5, g prime changes from negative to positive, so at -5, g has a local minimum. What they don't realize is, at x equals 9, well, g has been decreasing since g prime is negative from 0 to 9, and so g has a local minimum at x equals 9. And also, because, let's see, from -9 to -5, g is decreasing. G has a local maximum at x equals -9. And so because of that, you have two local maximums, two local minimums to account for, and you still have to evaluate g at -9 and at 0 to figure out which is the larger maximum. You have to evaluate g at -5 and 9 to see where g has a local minimum. So the easiest thing to do is just kind of avoid that work altogether and do the extreme value theorem, the candidates test, the table of values thing. So what we're going to start off with, let's change it into red, is continuity, right? In order for a maximum and minimum to be guaranteed, g has to be continuous on the closed interval 9 to 9. And so we can just say f is continuous on -9 to 9. So g is continuous on -9 to 9. And a maximum and minimum are guaranteed. Okay. And the next thing we should probably do, well, we already wrote g prime is equal to f. We're going to say g prime is equal to f, which is equal to 0, and these are our candidates, x equals -5, x equals 0. And we want to evaluate g at the endpoints, -9, -5, 0, and 9. And I'm going to write g of x is the definite integral from -3 to x of f of t dt. So I just remember what function I'm putting things into. Okay, so I'm going to need areas under this graph. So starting at -3, that's a 6, 3 wide and 4 tall. Another 6 from 0 to 3. I don't like putting on signs because I just have to decide later. So from 3 to 9, that's 6 wide, 4 tall. That rectangle has an area of 24. Over here from -5 to -3, that's 2 wide and 4 tall, area of 4, an area of 1 right there, and an area of 3 wide and 2 tall, 6. Okay, so let's try to look at all of that. So I don't have to worry about initial condition, and the definite integral from -3 to -9 is going to be -4 plus 1 plus 6, and I'm actually just going to write it that way. -4 plus 1 plus 6. Even though that 4 is above the x-axis, we're integrating right to left, so that's a -4. Okay, we actually do probably want to simplify, so that's 7 minus 4 is 3, because we want to choose the largest. Okay, so from -3 to -5, that's simply -4. Negative 3 to 0, that 6 ends up counting as positive. And from negative 3 to 3, well, I guess I could just keep going in line. Negative 6, or 6 minus 24. And hopefully you can see that's minus 24. So another thing that I saw on the test that people made an error on was a lot of people are just used to saying where the maximum and minimum occur, but this actually asks you to find the maximum and minimum, meaning the y values. So we can just say the global maximum of g of x on negative 9 to 9 is 6, and the global minimum, I'm going to skip over saying of g of x on negative 9 to 9, I think that's implied because it's part of the same sentence, is negative 24. I hope that helps.